In this video, I will explain determine the Fourier transform of the following functions. Determine the Fourier transform of the following functions. First one, x of t is equal to e power a t u of minus t. Second one, x of t is equal to e power minus a mod t. Third one, x of t is equal to e power minus a mod t into secant function of t. Solution. X of t is equal to e power a t into u of minus t. We know that Fourier transform of x of t is equal to minus infinity plus infinity x of t e power minus j omega t dt. We know that x of t is equal to e power a t u of minus t minus infinity plus infinity x of t is equal to e power a t u of minus t e power minus j omega t dt. U of minus t. U of minus t. The value of u of minus t is 1. T less than or equal to 0. And the value of u of minus t is equal to 1 for t less than or equal to 0. 0 for t greater than 0. Therefore, you consider minus infinity to 0. Minus infinity to 0 e power a t. U of minus t value is 1 into e power minus j omega t dt. That is minus infinity to 0 e power a minus j omega into t dt. Integral of this one is e power x is e power a minus j omega into t by a minus j omega. The limits are minus infinity to 0. E power 0 by a minus j omega minus e power minus infinity by a minus j omega. E power 0 is 1 by a minus j omega. E power infinity is 0. Therefore, Fourier transform of e power a t u of minus t is equal to 1 by a minus j omega. Coming to next one, second one. X of t is equal to e power minus a mod t. Mod t is equal to minus t for t less than 0. Mod t is equal to t for t greater than 0. This one is x of t function, two-sided exponential function. This one is 0, this one is positive t, this one is negative t. T less than 0 means in that region. X of t is e power a t. in that region e power minus a. T less than 0, x of t is equal to e power minus a mod t is minus t. It is equal to e power at. T greater than 0, positive interval, x of t is equal to e power minus a mod t is t, e power minus a for t greater than 0. Find out the Fourier transform. At t equal to 0, at t is equal to 0, the x of t is, substitute t is equal to 0, the x of t is e power 0, that is equal to 1. Finally, x of t is defined as e power at, e power at, t less than 0, 1, t is equal to 0, e power minus at, t greater than 0. By using this one, find out the Fourier transform. Fourier transform of x of t is equal to minus infinity to plus infinity, x of t e power minus j omega t dt. Minus infinity to, the interval is split it into 3 intervals, minus infinity to plus infinity, minus infinity to 0, 0 to 0 minus 0 plus 0 plus to infinity. At t equal to 0, t equal to minus infinity, t equal to plus infinity. Minus infinity to 0 minus x of t e power minus j omega t dt plus 0 minus to 0 plus x of t e power minus j omega t dt plus 0 plus 2 infinity x of t e power minus j omega t dt. Minus infinity to 0 minus the value of that means t less than 0. The value of x of t is e power at, e power at, e power minus j omega t dt, 0 minus and 0 plus the value of x of t, that means at t equal to 0, the value of x of t is 1, e power minus j omega t dt plus 0 plus and infinity x of t, that means t greater than 0, x of t is e power minus at, e power minus j omega t minus infinity to 0 minus e power a minus j omega t dt 0 minus 0 plus e power minus j omega t dt plus 0 plus infinity e power minus a plus j omega into t dt. Integral of e power a minus j omega t is e power a minus j omega into t by a minus j omega minus infinity to 0 minus plus e power minus j omega pi minus j omega 0 plus and 0 minus. Here e power minus a plus j omega t pi minus a plus j omega in the interval 0 to 0 plus and infinity. Substitute 0 here. 0 into e power 0 pi a minus j omega minus e power minus infinity is 0. Therefore, finally 1 minus 1 by a minus j omega. Here e power 0 by minus j omega. E power 0 by j omega. 0 is substituted here. Here e power minus j omega t. And here e power infinity is 0 minus e power 0 minus into minus plus e power 0 is 1 by a plus j. First upper limit is substituted e power infinity minus infinity, that is 0. For lower limit minus of minus plus e power 0 is 1 by a plus j. These two are cancelled. Therefore 1 by a minus j omega plus 1 by a plus j omega, a plus j omega plus a minus j omega. These two are cancelled by a square plus omega square. That is equal x of omega is equal to 2a by a square plus omega square. Draw the magnitude spectrum. Mod x of omega is also 2a by a square plus omega square. There is no j term. That a is equal to 1. A is equal to 1 or a less than or equal to 1. Therefore, mod x of omega is equal to 2 into 1 by 1 square plus omega square. That is equal to 2 by 1 plus omega square. If omega is equal to 0. If omega is equal to 0, the value of x of omega 2 by 1 plus 0 square, that is 2. If omega is equal to both minus 1, because here omega square is there, minus 1 and plus 1, 2 by 1 plus 1 square, 2 by 2, that is equal to 1. Get omega is equal to minus 2 and plus 2. Mod x of omega is equal to 2 by 1 plus 2 square. 2 square 4 plus 1 5, that is 0.4. If omega is equal to minus 3 and plus 3, mod x of omega is equal to 2 by 1 plus 3 square, 2 by 1 plus 9, that is 10, 0. By using these values, draw the magnitude spectrum. 0, 1, 2, 3. 0 minus 1 minus 2 minus 3. At 0 the value is 2. At 1 the value is 1. The spectrum is right. Next, third one is x of t is equal to e power minus at e power minus a mod t signum function of t. According to signum function of t, the value of signum function is 1, t greater than 0, minus 1, t less than 0. T equal to 0 is 0. Find out the Fourier transform of x of t is equal to minus infinity plus infinity x of t e power minus j omega t dt. T less than 0 means minus infinity to 0 minus x of t e power minus j omega t dt plus 0 minus to 0 plus x of t e power minus j omega t dt plus 0 plus 2 infinity x of t e power minus j omega t dt. Minus infinity to 0 minus, that is a negative value. Here x of t in that interval t less than 0, that means minus infinity to 0. T value lies in between minus infinity to 0. The x of t is equal to e power at. Signum sj signum of t is minus 1. That is minus e power 8. T greater than 0. T greater than 0, that means 0 plus 2 infinity. X of t is equal to e power minus a mod t is t, e power minus a t is sjn of t is 1. That is e power minus a t is 1. At t equal to 0, sjn of t is 0. Therefore, the entire interval is 0. That is equal to minus into 0 minus x of t is minus e power a t into e power minus j omega t dt. 0 minus and 0 plus at t equal to 0. At t equal to 0. 0 minus 0 plus sjn of t value is 0. Sjn of t value is 0. We need to calculate here. 0 plus 2 infinity x of t is power minus a t, this one, e power minus j omega t dt. Minus infinity to 0 minus, this one is minus e power a minus j omega t dt. 0 plus 2 infinity e power minus a plus j omega t dt. E power a minus j omega t by a minus j omega, this is minus sign, minus into 0 minus plus e power minus a plus j omega t by minus a plus j omega in the interval 0 to g. Substitute 0 here. E power 0 is 1. That is minus 1 by a minus j omega. Upper limit. For lower limit e power infinity, any e power infinity minus or minus infinity, that is 0. No need to write. Plus here upper limit e power infinity 0. No need to write. Lower limit e power 0 is 1. for lower limit minus of minus plus by a plus j omega. That is equal to LCM 1 by a plus j omega minus 1 by a minus j omega. A plus j omega into a minus j omega, that is a minus j omega minus a minus j omega, minus a minus j omega. A cancel, that is minus 2j omega by a square plus a plus jb, a minus jb, a square plus b square, a square plus omega square. That is the x of omega. With this, three functions of Fourier transforms are completed. If you like this video, please subscribe to the channel for further updates. Thank you.